Hi, today we're going to talk about using the binomial theorem to expand binomials with exponents. One thing you may remember from courses like Algebra 1, this is what they call the Pascal's triangle, and the way you form it is 1 in the first line, 1, 1 in the second line, 1, 2, 1. So each number that you get here, this number here that you get by adding these ones together, this number here is 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So anyway, this gives you expansion for, this is exponent 0, exponent 1, exponent 2, exponent 3. This will give you the coefficient. So for example, if I want to use this here to expand a plus b to the power of 3, this is going to give me, I apologize for the smudge, 1 times a cubed times b plus 3 times a squared b to b to the power 0, b to the first, plus 3 to the a to the first b square, plus 1 times a to the 0 times b cubed. So this is going to give you a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay? So, but we're not going to talk about this. We're going to talk about a more complicated situation when you have more complicated expressions and the higher degrees. So if you need to do something like this is a lot more involved than what I just showed you. And the other problem with Pascal's triangle, when you start expanding it, it gets pretty large. This is what the binomial theorem is. It tells you that if you're trying to write the expansion for an expression that looks like this, you're going to do, I will explain to you what that is in a moment, but it's going to be the sum of this expression. You're going to be adding that, so nk is going to go from 0 to n. Okay, so what's that expression in k? This is selecting k objects out of n objects. Another way to write that, maybe something that some of you might recognize, seeing it from courses like maybe even probability. So let's do a problem. We'll see how this actually applies. So here's a relatively simple problem. We need to write the expansion here, so it's the 6th degree. And let's set it up. So when we set it up, this is our A, this is our B. So we're going to start with selecting 0 objects out of 6 times. Then we're going to take x squared, which is our A, to the power 6 minus 0 times 3 to the power 0 plus 1 out of 6 x squared to the power 6 minus 1 times 3 to the first power plus 2 out of 6 x squared to the power of 6 minus 2 times 3 squared plus 3 out of 6 x squared to the power 6 minus 3 cubed plus, carrying on, it's going to be 4 out of 6. It's going to be x squared to the power 6 minus 4 times 3 to the 4th plus 5 out of 6 x squared to the power 6 minus 5 times 3 to the 5th plus 6 out of 6 x squared to the 6 minus 6 times 3 to the 6th power. So what's this thing here? This is basically a number of ways you can select 0 objects out of 6. I'm not going to spend time in this video discussing how you can do this with the expression that allows you to compute that. We're going to rely on the calculator. So this is going to give you 1 times x to the 12th times 1 plus, this will be 1 out of 6 items. There are 6 ways to do that. X to the power 10, 3, plus 2 out of 6. To do that, we can use a calculator. And on the calculator, we have this button that says, well, first we're going to type in 2. Then we're going to select math. We're going to go to this probability menu. We're going to select option 3. And we're going, oh, I'm sorry, we have to change this. This is 6, 2 goes here. Apologize. And it's 15. So it's going to be 15 x to the 8th power times 3 squared, which is 9, plus 3 out of 6. We do the same thing. That's 20. X to the 6th power times 27, plus 4 out of 6 will also give you 15. X to the 4th power times 81, plus 5 out of 6 will also give you 6 times x squared times 3 to the 5th is 243. And the last term here is 6 out of 6. There's just one way to do that. X to the power 0 plus times 6 times 3, 729 times 729. Okay. And all in all, we're getting x to the 12th plus 18x to the 10th plus 15 times 9 is 135. X to the 8th plus 20 times 27 is 540. X to the 6th plus 15 times 81 is 1215. X to the 4th plus 6 times 243 is 1458. X squared plus 729. This will be the expansion of that expression. We're going to take a look at one more. So this one's 2x squared times minus 3y cubed to the 5th. So we add a 5. So 0 out of 5 times 2x squared to the 5th power times, we're going to here use that with a negative sign, negative 3y cubed to the power 0 plus 1 out of 5. 2x squared to the 4th power times negative 3y cubed to the 1st power plus 2 out of 5. 2x squared to the 3rd power times negative 3y squared, y cubed squared plus 3 out of 5. 2x squared to the 2nd power times negative 3y cubed plus 4 out of 5. 2x squared to the 1st power times negative 3y cubed to the 4th plus 5 out of 5 times 2x squared to the 0 power times negative 3y cubed to the 5th. Okay, 0 out of 5 is 1. So that's going to be 32x to the 10th, that's 1, plus 1 out of 5 is 5, times 16x squared times negative 3y cubed, plus 2 out of 5, 2 out of 5 is 10, that's 8x to the 6th. I'm sorry, this was 8th power. 2 times 4 is 8. X to the 6th times 9y to the 6th plus 3 out of 5 is 10 also. It's going to be 4 times x to the 4th times negative 27y to the 9th plus 4 out of 5 is going to give us 5. So it's 5 times 2x squared times 81y to the 12th and plus 1 times negative 243 times y to the 15th power. And all in all, we combine this, it's going to be 32x to the 10th plus, that's actually going to be minus minus 240 x squared y, x to the 8th y cubed plus 720 x to the 6 y to the 6 minus 40 times negative 27 to 1080 x to the 4th y to the 9th plus 810 x squared y to the 12th minus 243 y to the 15th. Please note, when you have a minus, when you have subtraction, it is going to give you signs that are going to alternate. So it's going to go plus, minus, plus, minus, plus, minus, plus, minus, always. Okay. Next couple of problems. We're not always interested in finding the whole expansion. Sometimes we're interested in a specific term or specific coefficient. So if you look at example 3, it's asking us to find the 4th term. Remember, we start with k equals 0. This is term 1. 2 will give you, so it's the first term. Second, when k equals 1. K equals 2 is the third. And when k equals 3, it's the 4th. So this is what we are interested in. All we need to do is set it up. So it's going to be 3 out of 7 times 2x cubed to the power 7 minus 3 times 3y to the power 3. This is the setup. All we need to do is calculate this. So we do 7 out of 3. 3 out of 7. That's 35. This here will be power 4, so it's 16x to the 12th. And this will be 27y cubed. Multiply the numbers. This is going to give you 15,120 x to the 12th y cubed. This is our term. That would be the 4th term. Okay. And the last problem here is asking us to find the coefficient for x to the 12th. So here's the tricky part here. We need to figure out where exactly it is. So x to the 12th, when you use power 6, 6 times 3 is 12. So the first term, 18. The first term is going to have x to the 18th power. The second term, 5 times 3 is x to the 15th power. The third term is going to have x to the 12th power, and that's what we're interested in. I want to also remind you, when we tie this with the rest of the expressions, k equals 0, k equals 1, k equals 2, this is what we want. So when we set this up, this is going to be 2 out of 6 times x cubed to the power 6 minus 2 times negative 4 to the power 2. Okay? So 2 out of 6. Use a calculator for that one. Is 15. So this is 15. This is going to be, this is 4, so x to the 12th, just like we expected. And this is going to be positive 16. So 15 times 16 is 240. This is actually 240x to the 12th, but our coefficient is 240. I hope this helps.